Swayam Prabha. Digital India. Educated India.
Welcome back to infrared spectroscopy, guys. So we looked at each individual functional group and spectra of each of those functional groups, and we figured out what are the main absorptions that identify a functional group as such. And then we are now going to look at some problems or some spectra and try to guess what these molecules are. Here's a good time for you to hit that pause button, take out that notepad and work it out. When you come back, we will discuss them. All right. Welcome back again. So here is your spectra of a molecule. You don't know what it is. And where do you even start? First, as we did before, filter out the ones that you are going to have in most of the spectra, which is your alkyl groups. So, well, we don't have to worry about them. So you know there is a peak here that's really strong. That should give it away. But wait, there's more. There's here and here. Okay? Let's look at that. Whenever you have a very strong peak here, we know that that's a carbonyl. So that is a carbonyl peak around 1700, about 17, I would say 20. And here is, whenever you have a very strong peak, you have an overtone at exactly twice the amount. And so that's the overtone peak. And these, as we saw before, are alkyl, stretch and bend. These two, well, if you have a carbonyl and you have two strong peaks, that should give it away. That would be a, well, let's say this is a about 1050 around and 1250 around, and here is a dual peak, a pair. Okay, that is typically the CO stretches of an ester. So here, these are the things that really give it away that this is an ester. This is a C double bond O stretch. And this is a CO stretch. And we have two of them. And that's going to be indicative of an ester. All right, let's look at this one over here. We have, again, some peaks that may be due to alkanes, and let's look at what those could be. Yep, most of them, pretty much. So over here, and here, and here, and here's your fingerprint. It's hard to interpret every single small peak in here, so we are going to look at basically this peak right here, okay? So if you have an alkyl group, this is due to your CH2, stretch, CH2, and it's a doublet, so it's probably CH2 and CH3. And you can have a lot more, we don't know how many. And this is also due to your alkyl CH bends, and this is your alkyl CH stretches. Well, other than that, what do we have? We have here a very strong, I mean, this is not very strong compared to like a carbonyl, but this is medium, and between 2000 and 2400, we said there were only two things that really mattered. Triple bonds to alkynes, in alkynes, or triple bonds in nitriles. And if you look at the numbers really carefully, it's falling right in the middle of the 2000 and the 2500 line. So that is about 2250. This is your triple bond region, and in the triple bond region, it's 22 right in the center of that, and that is going to be a cyanide, a nitrile. Okay, so this is a triple bond stretch. If you have a carbon-carbon triple bond stretch, it's kind of weak, and it's about 2150 around here, somewhere like this. But this is 2250, and it's pretty strong. It's coming. It's a medium peak. You can't miss it. All right. So therefore, this we know is a cyanide. So therefore, this is an alkyl nitrile. Now, can we say how many carbons there are? No way we can do that, okay? But we can say that, I mean, it can be branched, whatever, but main thing is the functional group here that matters is the nitrile, and we're using IR to identify it. All right, well, let's continue over here. We got some peaks here, 4 spectra really. Let's look at them. Let's look at this guy first. Well, you really can't miss that broad peak, and we said broad is hydrogen bonded. So, and it's also a really symmetric broad peak here that's coming around between 33 and 3400. It's peaking out, and so that's typical of alcohols. That's right. Here's our CH, here's our CH, stretch and bend. So we're not going to really worry about these. So we know we have an OH here. Well, can we find out what kind of OH? You can. If you look at this, this is 1000, and so this is about 1100. If it's 1100, it's typically a secondary alcohol. Okay, so 3100 to about 3500 is a very broad peak, centimeter minus 1, broad and strong. That's indicative of an alcohol. And the peak at 1100, so this is your OH, and the peak at 1100 centimeter says this is probably a secondary alcohol. All right, this is probably a OH out of plane bend. Now, can we see anything else? Well, we don't have any stretches in the 1600, so it's an alkyl alcohol and not a aromatic alcohol. So this is a ROH, where R is alkyl. Do we know how many carbons? Nope. For that, you got to hold your breath and wait for NMR. If you're tearing your hair out for your IR, well, stop and spare them for NMR, because NMR is going to be a little bit more detailed than this, okay? So keep some of that your hair for later on, all right? We're going to get there soon. All right, let's look at this one. Here is a spectra, and again, this is your CH stretch, so it's alkyl. There is nothing here to indicate that it's an alkene or a benzene or a triple bond alkyne CH, so we only have CH here, but you got something here. Whenever you look at a spectra and the strongest peak is around 1700, that's where we should start. So we should start here. All right, so let's look at this one, 1700. If you have a 1700 around, that's where you should start. And then you look in this area to see if it's a aldehyde or a amide or a carboxylic acid or whatever it is. So here we have a peak around 1700, about 1750 you could say, and because it's right in the middle of 1500 and 2000. So 1750, you have a peak right here that is going to be indicative of a carbonyl stretch. That's always the most intense peak. What is it accompanied by? If you have a peak right here in the 2750, and you can see real clear double bonds, you can see here a nice doublet. So this is going to be around 2750 and 2900, and you can see a CH stretch of aldehyde. All right, you don't see any 1600 peaks for, to show that it's aromatic, so it's probably an alkyl aldehyde, RCHO. And this is just plain alkyl groups. All right, so alkyl aldehydes. Let's move on to this one over here and over here. Well, let's do this one first. Look at the spectra. It's just got a peak here and peak here. And this one has got a doublet, and 2 peaks here. What does that remind you of? And a tiny peak around here. Doesn't it remind you of this? That's right. It's just an alkane. All right. So here we have us alkane is 29, around 2900 is your CH2 and your CH3 CH stretches. And then we have, oh well, we already know these numbers, 1450 and 1375 are your CH bend, scissor, and wag, and so on that we looked at. And this is your outer plane, all right? So here's your CH. So this is just, that's all there is. So this is your alkane, your good old alkane. That's the simplest of all, okay? Let's look at this guy. Okay, well, looks like it's got a lot of peaks. However, a lot of them are very tiny here. These are probably overtones that it's hard to interpret overtones of these bends, all right? Let's look at this. This is the guy that's kind of going to give it away. There's nothing in the 1700, so you move on to this region. When you move on to this region, you got to make sure that you know where the CH bonds are. Okay, 2900 around, you have CH bonds. That's where they are. And here's your CH bend. So we know kind of this is for an alkyl group. There's nothing really that's very strong to indicate here that it's a benzene. Now over here, if you look at this, you can see that you have one peak and it's not very strong. And it's about 3300 is where it's peaking out. Okay, 3350 maybe. And there's nothing in this 1700. This is not an alcohol because an alcohol comes all the way down. This is not a carboxylic acid because a carboxylic acid we said is very broad. Therefore, this is probably an NH. Now, if you have NH2, you should have a doublet here, a double peak, but you don't. And if it's an amide, you would have a carbonyl here, and you don't. So it's not an amide, it's not primary amine. So therefore, by process of elimination, you can conclude that this is a secondary amine. Very good. So here we have around, in this case, around 3350, and it can be anywhere between 3100 and 3400, but this is 3350. You have an NH stretch, and that is a single peak or spike. And there's nothing in here. If it's an NH and it's not an amide and it's an amine, well, we should see some peaks for the CN. Do we see it? Yeah, you can see somewhere around, I would say 1150 here, you can see a peak, and that could be your CN stretch. And here's a very strong peak around 800. And these are all, the same wave number scale, and that could be your NH outer plane bend. Those can be very strong. So all of these indicate that what you have here is an amine. All right, so in conclusion, you have a spectra here that shows peaks that correspond to an ester. You have peaks here for an alcohol that shows that's a secondary alcohol. You have peaks here and here indicating that that's an aldehyde, an alkyl aldehyde. And here we have a peak over here that shows that this is going to be an alkyl nitrile. Here's a amine, and because you only have one spike, that is a secondary amine. Now, this one, really it lacks a lot of peaks, and it's a very bare bone spectra, and so that is your alkane. We will come back and do a few more problems. Talk to you soon, guys. If you have questions, don't hesitate to ask me. Bye.